Since I am not done with the PPT, just I am going with the whiteboard only now. So the next topic is high throughput computing. Okay. So now coming to the high throughput computing. So why require high throughput computing? So what is the purpose of having the high throughput computing? So when you take out about the high throughput computing, so the main thing which will be coming there in your high throughput computing is your task computing. Okay, the basic programming structure which you are going to have in this high throughput computing is task programming. So that's when you are going to use this one. So if you take the task computing, so task programming, when you are going to use it. So the first thing is when, why. Okay, as I told it, why we require the task programming. So when you are talking about why we require the task programming, so it is mainly used in this particular task programming. Why you require when you are going to have the multi-threaded programming only. So can anyone tell what do you mean by what is the difference between your task programming and the multi-threaded programming? Can anyone tell that one? If anybody knows the difference. So if you take the task programming, so if you take the multi-threaded programming, for example, so your task programming, what's the definition of the task programming? So it is going to just nothing but it is going to represent a program. Okay, your the task programming is nothing but it's going to represent a program. Okay, so then when it is representing a program, what it requires. So your task programming is nothing but what task computing or task programming. So generally a task, if you take, what do you mean by task is the first one. So it is programming is you are going to do the programming with respect to the task. So when it comes to the task, what the task represents a program. So if you take any program, so the if you take the represents a program. If you take a program, what the program should consist of? A program should consist of input, and the program will be having the output. Okay. So now when you are going to have the input and output, so once you are going to get the input, once you are getting the output, when you are going to get the input and the output, so how you are going to get the output you are going to get depending upon what? It depending upon the result of an execution. Okay, so you are going to get the output depending upon the result of the execution term which you are going to have. Okay, so that's what the task represents. Okay, so if you tell in the standard definition, so what do you mean by task? A task is nothing but a representing a task is generally represents a represents a program which requires an input file and the output file as a result of an execution. So that means whatever the output you are going to get, so you are going to get with respect to what as a result of an execution. Now, whatever the application you are going to build, for example, I am building the application. This thing I am going to get. So building applications you are going to take. So when you are talking about building the applications, how many tasks will be there? So if you take the build applications, so building an application requires what? N number of tasks. So your application is nothing but what? Collection of tasks which you are going to have. Okay. So building application requires a collection of tasks. So now this collection of tasks, what is going to have? So this collection of tasks are submitted for execution. Okay. So this collection of tasks which you are going to have when you are building the application. So this collection of tasks, if you want to build, if you want to run that particular application, that should be submitted for execution. Okay, that should be submitted for execution. So that is submitted for execution. What you are going to have. So when you are submitted for the execution, so with and after submitting the execution, what you are going to get? So after submitting the execution, you are going to get the output. So when you are going to collect the output, so you're going to collect the output at the end of the execution. So first is it is going to have building the application requires what? First it is going to have the collection of tasks. After collection of tasks, where the task will be submitted for the execution. Next, once it is submitted for the execution, so output is generated. So the output is generated. When it is generated, when the execution is completed, okay, or once at the end of their execution, output is generated at the end of execution is one term. So at the end of execution you can tell, or at the end of complete of the, or at the completion of the execution you can tell, at the completion of the execution you can tell, okay, completion of the execution. So this terminology is called as task. Okay. Now, when it comes to the task programming, this is also nothing but a collection of execution which you are going to have. Then what is the difference between your thread and the task programming? There is a difference between your thread programming and task programming. So if you take the thread programming, so thread programming and task programming, if you take, so in the, what is the difference between your thread program and task program? Your thread program is nothing but what? It's going to run within a single machine. Your thread programming is going to run within a single machine, whereas your task program, it is not going to be running in a single machine. So within a single machine, for what purpose you are going to use thread programming? To achieve parallelism. Okay. So to achieve parallelism, you are going to perform the thread programming. So that's what the definition is going to tell about. So when it comes to the task programming or task computing, so what it is going to have, what it is going to provide. So it is going to be providing the distribution by making use of the compute power of several compute nodes. Okay, so if you take about the task programming, so task programming is nothing but what? So it is also providing the distribution. It also provides the distribution by making use of computing power. Okay, by making use of computing power at different node. Okay, so computing power at different node you are going to have. So that's how it is going to be done. So that is how you are going to have different node is going to have. So that's how the task programming is going to work. So you are going to have the task programming so that it is going to provide the distribution by making use of the compute power. So where that particular compute power is to come, the compute power is to come at the several computing nodes. Okay, that the computing power is going to come at the several computing nodes. So now, normally if you take the task programming, what are the infrastructure is going to be used? So if you take the task programming, so computing programming all are same. So when you talk about the task computing, what is the infrastructure it is going to use? So what infrastructure is going to leverage? So can you tell, anyone tell what are the infrastructure is going to leverage? So if you take the infrastructure, as I told you that your task computing is, so it is going to run in a different node. So when it is done, when it is running in a different node, so how that particular, what are the different infrastructure we are to use? What is the infrastructure? Make your, what is the infrastructure the task computer is going to be make use of? So what are these infrastructure which are going to make when you are going to run your application in the different nodes? So we are going to make use of the cluster first. So cluster is one. Then you are going to have the supercomputer. Supercomputer will be there, and you are going to have the computer grids. So this is computer grids will be one of the infrastructure which you are going to make use to leverage the task computing. Now, to have this particular problem, so we are telling about task computing, high throughput computing, everything that it has to run in a different node, how it has to be performed. Now, after discussing all these things, so if I want to run my application in the different node, so for example, if I if I have the application is there, I have to run that particular application in different node. Okay, run application in different node. So when you are going to run that particular application in different node, so now how I have to do that one is the next question. How? So now I have the different system. If I have the supercomputer, so I have to contact that particular person, or you are going to have the data centers. So you're going to have the data centers here. The data centers I have to contact, and I have to distribute those applications among all these data centers, which are geographically connected outside the geographical location. Okay. So now when you are going to have that one, so it has to be obtain a huge power of demand for execution. Okay, so to have this particular term, we require what? So we have to take the support of some other infra provider, because every time if I want to run the application, every time I don't have the complex application to run, right? So normally most of the times I'm going to run the application within a single system. But when you require the application which is a complex work, when you have the work with, when you have to do the work with respect to the complex terminologies, you should have what we should have, we should have the more number of clusters of computer. Okay, more number of the cluster of computer it should be there, or you should have the supercomputers are there, or you should have the computer grids, or you should have the data centers which will be geographically connected across the globe. So now when you are achieving this, what do you require? So how you are going to obtain this particular solution is the next question. So when you are going to have this particular terminology, how we are going to get it is the next question. So now this particular solution can be achieved by what? So this particular solution can be achieved by the cloud. Okay, so what you are going to obtain? So this particular, you are going to leverage using the cloud computing. So that is, you are going to make use of the cloud computing is the terminology which you are going to make use of. So if you take the cloud computing, so what the cloud offers here next? So when you are talking about the cloud computing, so the basic features of the cloud is you are going to access the resources on demand. Okay, you are going to access the resources on demand. So now when you are going to have the cloud computing, so what is this, what is this going to obtain? So it is going to obtain a huge computing. So it is used to obtain the huge computing you are going to have. So it is going to use the huge computing you are going to have. And whenever you are going to have the huge computing, so it is going to be on demand. So it is going to provide you the solution for on demand for execution. So on demand for execution, then whether it is required to run that particular application which you have built in a single standalone system, when you are running that particular application in a single standalone system, whether you require the support from your cloud, no. So whenever you have the applications which has to run distributed, okay, whenever you are going to have the distributed type of applications, so whenever you are going to have the distributed applications, we are going to make use of what? Cloud computing. So now here, to have this particular application, I want to run the application remotely. Okay, so application has to run remotely here. So when the application has to run remotely, what it is going to have, it has to require some support from your system to the cloud service provider. Now that support, what you are going to get? So support from this is user, then this is cloud service provider. Cloud service provider will be there. Now to achieve the task computing, what do you require? Someone should be there in between your user and the cloud service provider. So that is called as what? That is called as middleware. So someone should be there in between your cloud and the cloud service provider, in between the user and the service provider. So to achieve that one, you require the middleware. So now, what is this middleware? So what middleware contains? What is the middleware is the next question which you are going to have. So your middleware is nothing but what? It's also a software layer. Your middleware is nothing but it is also a software layer. What is the purpose of using that particular software layer there? The purpose of using the software layer is that it is going to coordinate the usage of multiple resources. So the purpose is here what? The purpose is to use of multiple resources. Okay, use of, it is the purpose is to use of multiple resources which you are going to have. Okay, its purpose is to use the multiple resources. So from where you are going to take that particular multiple resources which you are going to have, because I'm going to have the software layer. Assume that I'm going to have the software layer here in between the user and the cloud. So there may be a number of cloud service provider data centers. Okay, so if you take this particular data center 1, so this is your data center 2, so this will be your data center 3. Now I'm going to take the leverage from the different service provider. So that means whatever the resources it is required to run your application, that particular resources will be drawn from the data centers, which is connected which will be geographically distributed across the globe. Okay, so this data center, it may be in India. So this particular data center may be in Singapore, and this particular data center may be in Australia. So those data centers are distributed across the globe. So this particular data centers are distributed all across the globe. So when it is distributed all across the globe, I have to access using uh, that particular resource. I have to use it, and I have to make use of those resources, and I have to create an local, and I have to create an environment where you have to run that particular application to get the result. Okay. So now, whatever the computing resources you are going to provide, so it will be differing from implementation to implementation, right? So whenever you are going to create some applications, whenever you are going to run some applications, so the applications which you are going to run, so if you take the task or application, task is running or application is running. If you take the application is nothing but what? Collection of tasks. So if you take the application is nothing but what? Collection of tasks which you are going to have. Okay, so when you are going to have the collection of tasks, when it is running, so now whenever you want to run, so it depends upon the implementation. Okay, so the collection of tasks, how that particular, from which data center I have to make use of the different resources. So what your middleware, what resources has to be retrieved from which data center, that has to be taken care by middleware, right? That has to be taken care by the middleware. So now when you are going to have this one, as I told you that, so you are going to have this particular feature, right? So this particular node will be there. So different service provider is there. So you assume that you are going to have the clusters here. So these are cluster. This may be a supercomputer. This may be a computing grid. Maybe there here. So now when you are going to have, so these are nothing but what? So these are nothing but the computing nodes. These are nothing but the computing nodes from which, so the user has to access from this particular system. So here the users you are going to there. So this user. So through this particular user you are going to have. So here you are going to have the middleware. So this is what you are going to have in the middleware. Okay. So when you are going to have this particular part, so it is going to access those resources. Okay. A task abstraction is going to be created with the different modes of distributed applications. Okay. So now I have to see that what operation I have to give to one cluster. So when you are going to have the application, for I have the application I have. So now I have to split the application depending upon the task which the application has to run. So now if you take the application, first I have to split the task. So please split the task. So if you take the application, what I am telling, application is nothing but collection of tasks. Now I have to have the property of splitting a task in such a way that which are the tasks which are similar to one another. Okay, which is not having any dependencies. I have to see, look after that one. So now I have to look for, I have to identify a here I have to identify a task which is having the common operations. Okay, which is having the common operations, I have to identify it, and I have to provide that one to that particular task. So I have to identify a task which is having the common operation. Once you have that particular operation, okay, so once you have that particular common operations, I have to execute in that particular node. Okay, so I will contact that particular middleware for the support, and I have to create and execute in the task based applications. What are the different mechanisms you should have at that time? Okay, so that middleware needs to be supported. So if you take the support from middleware, so if you take the what are the support from middleware which has been given, so what are the different support it is going to give? Now if I want to give that particular task to that particular node, so if I, for example, so you are going to have the middleware, so you are going to have the collection of task here, collection of task. One task may be given to this particular cluster, another task may be given to this particular supercomputer, one task may be given to the computer grid. When you are going to have this particular type, so now how the coordination has to be done now. So what are the different factors I have to look upon? So when you are running applications with respect to when you are running a collection of tasks, what are the different features you should have? So now, what are the different features you are going to have? Because you are going to call it as supercomputing nodes. Now, when you are going to have the different computing nodes, so the computing nodes should have some coordination, right? So first, it should have the support. What you are going to get from the middleware is first it is coordination and scheduling. Coordination should be there, and scheduling of different computing nodes should be there. Coordination and scheduling of different computing nodes. Coordination and scheduling at remote nodes you should have. So coordination and scheduling at the remote nodes. Now, when you are moving a program to the remote node, what is the other term? What I have to do that one now? I have to manage that particular program which I have moved to that particular remote node. So now when you are moving that particular remote node, I have to keep another factors into my consideration. What are those factors? I have to look into that. The dependency should not there be between one node to the another node. So I have to look at whether any dependency is there between one application to the one task to the other task, which is running in a different computing nodes. Okay. So if you are going for the movement of the computing node, so movement of computing node, what it is going to have? So if it have the movement of computing nodes, so these computing nodes are running where? So remotely. This computing node is running remotely. So now, if your movement of computing nodes are remote, should manage, okay, should manage of their dependencies. Okay, so of their dependencies, I have to see, and whether it is going to have that particular part, I have to look into, and depending upon that one, I have to manage that particular dependencies, which is running an environment. So now I have to create an environment. So third support which you are going to have from the middleware is, so I have to create an environment in such a way that the execution has to run smoothly. So third is working, but what I have to check for whenever coordination and scheduling has to be done by at the remote nodes, and I have to see that whether any computer node should be managed to have the similar type of execution is there, or very dependency is there between one task which is running in one node to the another node. And third is I have to create an environment. Okay, so third is I have to create an environment for execution at remote nodes. Okay, so you have to create an environment for execution of remote node, so which you are going to have. So this is the third point which you are going to have. Now after doing that one, what I need to have, what is the other task of the middleware? So once I have been created the environment for execution of remote node, whether my work is over? No. Once you are a manager, what you have to look? As a manager, you should keep on looking that whether that particular work is completed or not, right? So now what I need to look for that one, till the completion of the task in the remote node, I have to keep updating the status of the remote node, whether that particular remote node is working or not. So that has to be done. So how we are going to do that one? I have to monitor, right? I have to monitor the task execution at remote node. So task execution, I have to monitor it, and status, I have to update it and inform the status of execution. So now, once it is done, once you are going to get the output from the different remote nodes, so you're going to have some resource, what will happen, some uh, task requires some resources from your data center, some task may require the data from your computing nodes, and some task may be requiring the data from your another service provider. So at that time, what will happen? So it hacks access to output, and you should have the access to the output. So during that particular time, you should have the access to the output produced, access to the output produced by the task, access to the output produced by the task you should have. So this is how it has to be done. So you have to take care of that particular part. So how it will be done. So this is about the basics of your task computing. Once it is done, you should know what are the different characteristics of task. How the task represents. What is the proper? What should be the characteristics of task? So next, when it comes to the characteristics of task. So when it comes to the characteristics of task. So anybody having any doubt till now? Anybody having any doubt? So a task is nothing but what? Which is running. If it is running by a program, it will be running in a remote node. That's it. So if you are taking the, if you want to achieve the parallelism with respect to the uh, uh, application which is running in a different node, we are going to make use of the task. Now, so we have seen that when you are defining the task, so the task is nothing but what? It's a program or combination of program. Okay, so that when you are going to have the combination of program, or if you want to run a program, to run that particular program, you require one computing unit. So when you are going to have the computing unit, which is having the distributed application, then the characteristic of that particular task should be different. Now, so what it is going to represent. So when you are going to have the characteristic of the task, what it is going to represent? It represents a component. Okay, you can see it here. It represents a component. What component it is going to represent? So it is going to represent a component of an application which has to be running. Okay, so it represents a component of an application. So what it should have, that can be logically isolated and executed separately. Okay, that can be logically isolated and executed separately. Okay, and executed separately. Okay, now to achieve this one, so when you are talking about the distributed applications, so your whatever distributed applications consist of, your distributed applications consist of number of tasks. So now when you are going to have the number of tasks, whose collective execution which you are going to get. So we have collective execution which you are going to take, that should be have the interrelations between the defined and interrelations which you are going to have for that particular task. It will be defined depending upon the nature of the application which you are going to run, right? So I should have the task. So if you take the task, so if so our program, if you take the application, I'm going to create the number of tasks, right? So if it is task 1, task 2, task 3, so I'm going to give to one remote node 1. I'm going to give it to remote node, this particular remote node, this particular remote node, this particular remote node I'm going to give. So when I'm giving this particular remote node, the particular task, I should have to know that what are the interrelations between them. So what is the relation between this particular task which is running in this particular node to this particular node? So task relation should be there. So task relation, what's the task relation? This particular node and this particular node. So if you have going to have task relation, what is there? That you should know. So task relation which you're going to have. Okay. So what are the task related consist of? So task may be related of a shell script composing together the execution of several applications, a single program or unit of code which you are going to have. Okay. So a task is generally what it is, how it is characterized. So it is characterized by what? So if you take the task, so task is characterized by, so what you are going to have that particular task, a task should have an input files. Okay. A task would one input files should be have. So if I'm going to have built already the object code, so you should have some executable code should be there. So some executable code, so like programs or shell scripts which you're going to have. And after that one, you should have what? You should have the output file. So these three things which you're going to have has to be defined by your task. So now when you're writing your task, so you should also have some software appliances. Okay, you should have also the software appliances which will be running on the remote execution node. in addition to the library dependencies. Okay, so we are going in the middleware. What will happen in the middleware? You're going to have some set of libraries. So using that particular library, you're going to execute the application at the remote node. So when you're going to have the application which is running at the remote node, so I have to see that what are the different library dependencies which are there. So if there is any dependency, I will transfer that particular library dependency to that particular node to execute, right? Because you require the resource from some other node when there is a dependency. So now, doing this particular type of task which is running came into picture, they should have some additional constraints which you are going to have. Okay, so these are the things which you have to see. So next, when it comes to the computing categories, so if we talk about the next is what are the different task computing categories or computing categories you are going to have. So in the task computing categories, first it is HPC. HPC stands for high performance computing. So HPC is high performance computing which you are going to have. So this is high performance computing. Second, you are going to have HTC. So it is high throughput computing. So first is high performance computing. Second is high throughput computing. So third is many task computing. So third it will be many task computing which you are going to have. Okay, so it's going to have the many task computing. Okay, so these are the different tasks which you are going to have. So once you have this particular high performance computing, so when you are going to have the high performance computing, so what your high performance computing requires? So if you take the HPC, so HPC, what it requires, HPC, as the name suggests, it is high power computing. So as the name suggests, it's high power. So whatever the distributed computing facilities you are going to have, so distributed computing facilities which you require. So distributing computing facilities which you should have high processing power. Okay, or it requires high distributed computing facilities for what you are going to have for solving complex problem. So you require the distributed computing facilities for for solving the complex problem. So when you are going to have to solve the complex problem, so here you require large computing power. So you require the large computing power you require. So large computing power you require. So now I require only the large computing power. So whether the unit of work done with respect to time, I don't have consideration of that one, right? In this one. So now here, so you have to keep in mind that, so whatever the large computing power you are going to get, so it has to be achieved. Okay. So it has to be achieved in short period of time. Okay. It has to be achieved in short period of time. So that you are thing you have to keep in your mind when it comes to the high performance computing. So that will be in terms of teraflops or even petaflops it is going to have. So number of flaps per second. So floating point operations per second. Okay, so flops refers to floating point operations. Okay, so it is going to have floating point operations per second. So whatever the operation you are going to have. So when it comes to the high throughput computing, so next is HTC which you are going to have. So here it is high throughput computing. So when you come across your high throughput computing, so throughput is the but what? So it is also the same thing. You are going to make use of the distributed computing facility. So distributed computing facility you are going to have. So here also you are going to have the distributed computing facilities which you are going to have. Once you have got the distributed computing facilities, that particular computing power. Okay, so here whatever the computing power you require, so the computing power is required for longer duration of time. So here computing power is required for larger duration of time. So there in your high power computing, it is shorter duration of time. So whereas your high throughput, you should require for longer duration of time that it should run. So you should have the support of your remote desktop machine. Okay. So those tasks which you are going to have, so that will be running for weeks or months. So here, whatever the program you are going to have, that will be running for weeks or months. So here, what are the some of the application is like weather forecasting should be there. That weather forecasting has to be done daily. Okay, so how the data, how they are going to forecast, the forecasting of the weather will be done depending upon the weather which is there at the place which is far from our place, right? It may be around 500 kilometers or 600 kilometers. So you may have gone through that. If there is a cyclone in Arabian Sea or Bay of Bengal, so we are prone that the Bangalore is going to get the rain. How we are going to know that one? But they will tell sometime that after 2 days the rain will come in Bangalore. So, but it will not come. What may be the reason for that one? So if we take the weather forecasting as an example, if we take the weather forecasting, so here forecast initially they will tell rain will come, but after that one the rain won't come for that particular duration. Why is the next? So because the cloud movement depends upon what? The cloud movement, if you take, it depends upon the wind. So if the wind changes its direction, obviously the movement of the cloud will also change its direction. So if the movement of the cloud changes, obviously what will happen? The rain which has to be supposed to come in Bangalore will be shifted to some other place, depending upon the direction of the wind which it is moving. So if the wind is moving towards the Bangalore only, then the wind will come, wind will direct the cloud to move to the Bangalore, and in Bangalore it will be raining. That's how it will happen. So when they are going to have this one, so the prediction matters there. So then the processing has to be done for longer duration of time, right? So when you are going to have the prediction longer duration of time, you are going to make use of the high throughput computing. So the last type category which you are going to have is many task computing. So in the many task computing which you are going to have, so it is going to model started with receiving attention. So it is having the wide rate of applications. So it is nothing but what? So it is going to have the between. So it is going to bridge the gap between the both gap of your HPC and HTC. That is high performance computing and high throughput computing. So now, when it comes to the some of the frameworks for task computing, so there are several frameworks which you are going to have. Okay, so that we will discuss in the next class. Just I will tell you what are the different frameworks for the task computing. So when it comes to the frameworks for task computing, so there are several frameworks are there. So first is Condor is one of the framework which you are going to have. Then you are going to have the Globus toolkit which you are going to have. Condor, Globus toolkit. Then you are going to have SunGrid engine. So fourth one you are going to have Boeing. Fifth is Nimrodal G. Sixth is your Aneka. So these are the several frameworks which has been designed for task computing. So we are discussing with respect to the Aneka most of the times here, but the frameworks for task computing depends of classified into what? So your depends upon Condor, Globus Toolkit, SunGrid Engine, Boeing, Nimrodal G or Aneka. So we will discuss one by one in the next class. So before that one, so now when you are going with this one, so if you take the architecture, of this particular computing, so if you take the architecture is common for all, because the architecture will be having what? So your remote machines will be there, user 1, user 2 will be there. So just go through the notes, the textbook, how the figure is represented, you write in that manner. So here, so for understanding purpose, I'm writing in a simple way, that's it. So you're going to have the middleware here. Okay, so you're going to have the middleware. So once you are going to have the middleware, you are going to divide the number of tasks. If a number of tasks, I'm going to run in different remote nodes. So I'm going to run these particular in the remote node. Okay, so that is going to have the run in different remote node here. So even if I'm going with that particular application, the task, so the task can be running in your local node also. So if it is a multi-threaded, so if it is no complex operations are involved. So if it is a multi-threaded programming, that particular task will be running in remote node only. So but it is a complex operation. So if it is a complex operation which you need to perform, if you require a complex operation to be performed, then it is going to make use of different frameworks. So the frameworks which you are going to have here in this one is Condor, Globus Toolkit, SunGrid Engine, Boeing, Nimrodology, and Aneka. So this is important for examination point of view. So whatever how the frameworks of the Condor is built, a Globus, all this either whether if you go with the Condor or if you go with the Globus Toolkit or if you go with the SunGrid Engine or if you go with the Boeing or if you go with the Nimrodology or if you go with the Aneka, all these frameworks will follow the same architecture. So the architecture of all these systems are same, okay, which is similar to this particular architecture, which is general architecture. So that is going to have the user in the middleware and the remitting node. So in the remitting node, depending upon the different resources, you are going to execute it. So apart from that one, you are going to have the remote execution environment should be there, remote execution environment, so that will be done. So this is what the similar architecture which is showing to run the task applications. Now, when depending upon the different, so now if we take the any framework, so now if we take the two main nodes you should have, okay, you should have the two main components of this task computing system should have. What are the two main components which you're going to have? One, you should have the scheduling node. That means the task has to be scheduled, right? So I have to schedule that particular node. So other is called as worker node. So you're going to have two different components which you're going to have in your framework. So the two different components which you're going to have in your framework is one is your scheduling node, other is your worker node. So now the organization which you're going to use with the different frameworks may vary from different to different. Okay. So these are some of the basics. So tomorrow we will start with how your Condor is going to work. So I cannot start now because it will take the time. So it will take another 5 minutes to explain the Condor. So it is the most widely used middleware. So your Condor is the most widely used middleware which is happening. So it is mainly used to manage the clusters. Okay. So and it is going to be make use of the available the idle stations are there, and it's going to have the collection of workers. Okay. So these are the things which you need to know about the task computing. So now, if you have any doubt from today's class, you can ask. If anybody is having any doubt. So if you are covered with what is task computing, why it is used, what's the difference between your task computing and the multi-threaded programming. Okay. So you should know all these differences. So if you have any doubt, you can ask. So go through it, whatever I have done. So if you have any doubt, how to access to the output